Let's see the formulas for the areas of the most common geometrical shapes. The rectangle is the easiest one. Almost by definition, we say the area is base times height because of the very definition of a square unit. As we can see here, we have here 4 times 3 units, which gives us 12 square units. So that's the most basic formula, and from this formula we are going to get all the others. If we tilt the rectangle to one side, we get the rhombus rhomboid. But in this case, the area we lose on one side, we gain on the other side. So the formula for the area stays the same. The areas of the rhombus or rhomboid is base times height, the same as for the rectangle. If we divide the rhombus in two halves, we get two triangles. So for one triangle, the formula of the rhombus gets divided by 2, and we get the formula for the triangle. Let's go back to our rectangle and let's change it into a trapezium. In a trapezium, we have two bases, a long base and a short base. So which one should we use for the formula? Well, as we can see here, if we average both bases, we get the area of a rectangle, which is the same as the trapezium, because the triangle we lose on the top, we gain on the bottom. So that's the formula we need. The average of both bases times height. For a regular polygon, any number of sides, we need the length of one side and the distance from the center of the polygon to the center of the side, which is what we call the apothem. With the apothem on the side, we can see here that we have a triangle, and we can find the area of this triangle, which is base times height divided by 2, so S times A divided by 2. We can see as well that we have as many triangles as sides, so we have to multiply this by the number of sides of the polygon. But the number of sides times the length of one side is what we call the perimeter of the polygon. So the formula gets area equals perimeter times apothem divided by 2. Here we have another formula for the rhombus, when instead of base and height, we are given the length of the diagonals. As we can see here, we can divide the rhombus in two triangles. The area of one of the triangles is base times height divided by 2, so d times the halves divided by 2, which is, if we simplify that, is the product of the diagonals divided by 4, but that is just for one triangle. As we have two triangles, we multiply that by 2, which, simplifying, we get, in the end, the product of the diagonals divided by 2. Finally, for the circle, an irrational amount is involved. We need a radius, and we need an irrational number, which is called pi. Pi is a decimal number with infinite decimal figures that never repeat. The area is given by the formula pi times r squared, and the perimeter is given by the formula 2 pi times the radius. If instead of the circle we want to find the area of just a circular sector, we need to know the angle of that sector. and then we apply proportion. So we find the area for the whole circle, divide that by 360 degrees, which is the angle of a whole circle, and multiply by the angle of the sector given in degrees, of course. For the perimeter, we would do the same, only that in this case, instead of the formula for the area, we use the formula for the perimeter, 2 pi r divided by 360 and multiplied by alpha. But in this case, we have to add the two radius, which are part of the perimeter of the sector as well. So that is plus 2r. And simplifying, we get pi times r divided by 180 times alpha plus 2r.